confirming the fact that, at the present time, Germany has not produced a substitute to compete successfully with cotton. A chemist and inventor recently interviewed in this country brought to light a story of years of research in an endeavor to secure a fiber which might replace cotton in strength and cheapness. His work has been mainly along the line of nettles and hemp, and he has rather a complete line of goods representing the manufacture of fabrics from these fibers on a commercial scale. Attempts made in Germany. From time to time, the textile world has been entertained by reports regarding cotton substitutes, and these have increased in number during the war as the result of many and varied experiments in Germany to meet the critical situation arising from the shortage of cotton. From reports which have reached this country, there appear to be 4 different products of more or less value resulting from the endeavors to replace cotton. The first is textilose, or paper yarn, which has probably created the greatest popular interest. Its strength and wearing qualities, however, are said to be too inferior to make it a serviceable substitute for cotton proper, and its use will probably be confined to a limited field, such as substituting for burlap in certain instances. The second fiber is cellulon, a material produced in a similar manner to artificial silk. Wood pulp is dissolved, and the resulting cellulose mass forced into threads through fine holes and then treated in various ways to procure hardness. One of the methods described has been treatment in a bath of casein and then immersion in solution of formaldehyde with final treatment in a heat chamber. It appears that this fiber has a future for use in substituting inferior cotton goods not submitted to heavy wear and tear. Nevertheless, it probably will have to be confined to yarns of low count, 10 singles being mentioned as the limit. Another class of substitutes tried in Germany consists of fibrous materials, such as obtained from the typha plant, known in America as cattail or reed mace. These appear to be of very little value for spinning by themselves on account of the shortness of the fibers, but may be serviceable with mixtures of longer staples. The fourth and last class is nettle fibers. Germany has apparently not yet produced an economical and serviceable fiber from this plant. Problems connected with the growing of the nettles and their cultivation, together with more complicated ones related to the decortication and degumming of the fibers obtained, do not appear to have been successfully resolved. The nettle plants, it is along this line that the chemist referred to above has devoted most of his attention. The use of nettles is a revival of olden times, as nettle fibers were at one time largely used for homespun fun fabrics, distinguished by excellent strength and wearing qualities. China still uses the fibers of Bochmeria nivea, a species of the nettle family, for the production of the so-called grass cloth, a durable fabric made by hand. While the nettle fiber cannot be considered as a general substitute for cotton, it can be used for certain counts of yarn intended for special fabrics. It is stated that no attempts should be made to use this fiber for higher counts than 24 singles, as nettle fibers are of a heavier body than cotton and have a limit for use for spinning high counts. Above 24 singles, the production of a regular and even yarn is somewhat problematical. Nettle fibers should be preserved for special purposes where excellent wearing qualities count and spinning over 20 is not required. Cloths in which it is especially useful are tropical cloth, toweling, etc. It would further replace cotton to advantage in the manufacture of half-woolen goods, cloth, blankets, hosiery, etc., and also in cases where, heretofore, China and Peruvian cotton was required. There are many varieties of nettles which may be used interchangeably, and it is stated that practically no difference in the fiber from these varied species can be noted, or at least no more than might occur between different fibers from the same species. This country offers the opportunity of growing any of the following varieties: Bochmeria, Urtica gracilis, Dioica Laportia canadensis, Parietaria. Experiments in southern Germany have been mostly with Urtica dioica. The plant requires a soil rich in nitrogen and with some moisture. Consequently, the great tracts of land in the Everglades section of Florida are considered ideal for nettle cultivation. Successful cultivation of the nettle plant has been carried on in Staten Island by the chemist interviewed, and he states that he has obtained 2 crops a year. He believes that 3 crops can be grown in the southern states. The nettle plant has as a byproduct an excellent cattle fodder in its leaves, containing 25% of protein. Consequently, the cost of production can be cut down by the utilization of this food. Obtaining the fiber. Nettle stalks cannot be retted in the manner of hemp and flax. The inventor referred to above has worked out a method of treatment which has given satisfaction. The best time to cut the plant for production of fiber is when it first starts to blossom. Stalks are then placed in a decorticating machine for the separation of the wood from the fiber. The latter is then treated chemically in order to remove the natural oils, gums, etc., and to separate the individual fibers. In this process, the fibers are boiled under pressure with a chemical solution. After coming from this treatment, they are run under corrugated rollers for preliminary pulling apart and are then carded in the regular way. Spinning may be done on the standard machinery used for cotton. Illustrative samples demonstrating the whole process in its entirety allow the following conclusions. Nettle fibers may be produced in strictly ultimate elements in length from 2 to 6 inches. Such fibers are easily turned into yarns of different kinds, regular and even, of good tensile strength. Fabrics made from such yarns make a good showing. The fibers mix readily with wool. Garments made from nettle cloth, white and dyed, from menswear, tropical garments, etc., demonstrate the excellent wearing quality of such cloth after years of heavy wear and tear. It is claimed that a clean nettle fiber ready for spinning may be produced to sell with a profit of 7 cents per pound. End of experiments with nettles as a substitute for cotton in World War I from the Textile World Journal, March 1919. Read for LibriVox by Sue Anderson.